How much would you be willing to spend on this robot? And what task should it learn next? Today on AI News, we're examining the future of autonomous humanoid execution across 9 tasks of increasing difficulty, starting with Figure 03 Humanoid opening up a door. And while this may look easy, this includes repositioning its body as it swings. Next, you're going to see it grab this coat with both of its hands. This is a deformable object. Third, see the robot pushing in this chair using its feet to negotiate its weight. Fourth, it shuts the laptop. Fifth, repositions these headphones. Now on the right, you see the 6th task is that this robot picks up this book and closes it with one hand. And on the left, you see this robot do the 7th task, which is throwing away the trash with one of its feet. Now, here's the magic. Both of these robots go over to this bed and they begin fixing the pillows. But what's really impressive here is this 9th task of grabbing this duvet and working together to unfurl and spread and fold this comforter. Along the way, they're correcting these wrinkles and unbunching it. And while they do this, they're trading information back and forth. Each task that one robot does creates a reaction for the other. Now, this is quite impressive. Look at how they fold this blanket using their hands to create a crease. And then they even pull it down. But while this task may look simple, there's actually a hidden fundamental breakthrough happening that you might not have caught on the first time. So let's take one more look, because behind every smooth motion lies a hidden hierarchy of complexity. So number 1, there's the sensory paradox, which is turning raw visual data into precise physical contact. Number 2 is the stability threshold, which is required to maintain balance while shifting centers of mass. And number 3 is the logic of calibration, where 2 independent minds have to act as one. In fact, what makes this sequence a breakthrough isn't just the presence of the 2 robots, but the staggering amount of physical and computational noise that they have to navigate through simultaneously. And to appreciate the engineering hurdle here, we have to look at how 3 distinct challenges amplify one another, starting with number 1, the multi-agent feedback loop. So running 2 humanoids in a shared workspace is far more complex than doubling a single robot task, because it creates a dynamic feedback loop where every action is a reaction. So if robot A pulls on a blanket, it changes the physical environment for robot B in real time. And because this is completely autonomous and it's not a hardwired script, each unit must treat its partner as a massive, unpredictable variable. And they have to infer intent through visual observation, as well as reading the subtle shifts in their partner's posture to predict where the tension in the fabric will go next. And that brings us to number 2, the chaos of deformable objects, because unlike a rigid box or a heavy tool, a comforter has an infinite number of states. It drapes, bunches, and slides, and there's no fixed handle to grab and no correct geometry to reference. And in a collaborative setting, this becomes a tug-of-war of physics because of the shared tension, where if both robots pull too hard, the fabric slips, and if they don't pull enough, it bunches. Plus, you have occlusion, where as each fabric folds, it hides the very contact points the robot needs to see. And each robot has to commit to a grip while simultaneously predicting how the fabric will deform based on the other robot's movements, updating these micro predictions dozens of times per second. But it gets even harder because of number 3, continuous local manipulation at scale. This is because the most subtle difficulty here is the sheer duration and variety of the sequence, as this is one large uninterrupted sequence of high-stakes decision-making, with 3 critical ingredients. The first being locomotion, where they're navigating the room with a natural gait. The second is dynamic balance, where these robots are shifting their weight to manipulate different objects. And the third is articulated manipulation, where they're handling hinged or sliding objects or deformable objects. Furthermore, performing thousands of consecutive correct actions without a single scripted handoff means the neural network here is constantly interpreting a fast-moving scene where each robot has to follow the calculations of the other in real time. And what it all means is that we're moving away from specialist robots that only know how to do one thing and towards collaborative generalists. But what do you want to see Figure 3 do next to make it a viable purchase for your home or office? But as humanoids are beginning to master the physical world, Anthropic is also beginning to master the financial world with the launch of 10 purpose-built AI agent templates designed to automate high-intensity financial workflows, such as building pitch books, screening KYC files, and managing month-end closes. And it's all optimized for the Claude 4 model family, where these agents can operate as managed agents running autonomously on the Claude platform to handle long-running deal cycles and complex audits with full compliance logging. And on top of this, Anthropic has also announced the integration of Claude into its Microsoft 365 ecosystem, introducing a suite of specialized tools which are all designed to embed AI directly into enterprise workflows. And this focuses on deep integration with applications like Outlook, Word, Excel, PowerPoint, and SharePoint, which positions Claude as a native assistant within the productivity suite. And the integration utilizes a secure, enterprise-grade architecture that prioritizes data privacy and compliance. And according to Anthropic, the Microsoft 365 version of Claude can analyze and synthesize information across various document types while maintaining its users' existing security permissions. But beyond the physical world and the corporate world, AI is even managing human health, as Google just launched Google Health Coach, a multimodal AI wellness companion within the rebranded Google Health app. And it's built on Gemini's architecture, with the service consolidating fitness, sleep, and medical data into a proactive conversational interface, which moves beyond static goals and instead adjusts wellness plans in real time based on activity, sleep quality, and environmental factors. Beyond that, a key feature is its multimodal logging, allowing users to track nutrition via photos or report workouts through voice and text. And for users in the US and Japan, the coach can even ingest personal medical records to summarize complex lab results and then connect them to daily habits. Anyways, if you want more on the latest in AI and robotics news, like and subscribe and check out this video here. Thanks for watching.